Morning, everyone.
Morning, every. Good morning.
Good evening to Boone, I guess. What time is it for you, Boone?
1 o'clock.
1 a.m. So do they call it good morning or good evening?
Morning, I guess.
Okay. Oh, good morning. Then. Hey, Tony.
Hey, David.
Tony, do you know if John Chaka will join us today?
I do not.
Do you have a way of pinging him?
I'm sorry?
Do you have a way of pinging him?
Yeah. Let me forward this. What about Mohammed? Have you copied him on this call?
No.
Yeah, you need to do that. He's our SIPI guy,
Okay.
and
I
John's.
have. Okay. So, so you know that I don't have a way of doing that, right?
Yeah, I know that. I know
Okay.
that. But you can help them get it on their calendar. I'm just going to forward the old invite here. It's every 2 weeks.
SIPI, yes.
Yeah, so I'm just going to forward him the standing invite that's on my calendar, but we need to get them to make sure they're on the right.
Okay. So I think you asked me to resend the instructions for setting up Outlook for this
Yes.
meeting, and I
Yes.
did recently. I remember.
It was about a month through, at least 2 or 3 weeks ago. But yeah.
Yeah. So
Right.
maybe.
I'm going to reach out to Teams, see if I can get them.
Okay.
Looks like he's offline.
Okay. Oh, okay. So here's Muhammad. Good. All right.
All right. I pinged them both on Teams as well. So.
Yeah, I see that Muhammad has joined us. So
Okay.
that's good.
Hey everyone, yes, I'm here.
Hey, Muhammad. So Muhammad, were you in this meeting a couple of weeks ago when I was talking
No.
to John Chaka? Okay.
Hi, Monday.
Have you? Oh, hey, John. How are you? Good.
Good. Thanks.
All right.
Sorry, I was just wrapping up another call.
Okay. So last time when we talked about SIPI stuff, right? We talked about what parameters do we need to capture. I remember, John, you were going to take a stab at that. I was wondering if you may have any update.
I don't, Dave. I'll put that on the agenda for this week. I got lost in the fray, so that's apologies on that one.
Okay. So okay, that's okay. I should have given a heads up. Okay, so we are a little bit out of sync on this one. Let's. How about we do this? How about we do a little bit of high level work right now? We can scrub what we have captured, and then we can have a final version. I mean, finaler a version for the next meeting in 2 weeks.
David, the last I looked, there was no spec. Do you have anything written down in terms of a spec on this?
Okay, so let's see. No, so we are working on the spec, Tony. The way, okay, let me see what's in the folder. I know
I mean, if there's anything, I'd like to look at it, and maybe we should share it with John and Mohammed.
Absolutely,
let's
Tony.
see.
Yep, that'd be good.
Okay. Actually, no, there is no spec, but
I didn't
take
think
a
so.
take a look at this. Let me post it in the chat. Okay, here we go. This is doc. Actually, I had forgotten about it. Thank you, Tony, for reminding me. So this document, which I'm going to share my screen in a moment, so you know when I say this, what I mean by this is. This is the way this document is. What's in this document is the following. I had a few meetings late last year with JP and Pratyush and the team here, and we went over some of the parameters that we want to capture. Okay, and kind of captured it in the meeting minutes what we talked about. Then these meeting minutes, I took them and copy pasted them into a white paper template. This is what you're going to see here. Most of this document is the white paper template, except when we get to section number 3. Section number 3 captures, is basically copy paste the meeting minutes from the README file. Mostly copy paste. So you can take a look at some of the high level stuff that we discussed, see what needs to be added, what doesn't need to be added. Now, let me pull up another document. Give me 1 second.
Is this document posted someplace?
This document, yeah, it's on the Google Drive. This in the Google Drive area.
All right, can you send a link to it?
It's which document? This one?
You just did. Okay, you just.
Yeah,
Okay, got it.
That is the same document.
Yeah. Okay.
I want to pull up another document. If you give me a moment. What I wanted to pull up is the okay. This is what I'm pulling up is this document. This is in the contribution open compute contribution database. So let's see if this will work. Theoretically, this link that I'm about to post in the chat should take you, let's see how this works. It should take you to this page. So this is the same document here. Let me post this in the chat as well. Okay, here we go. So let me get back to my thought while I was looking for this document. The reason I was looking for this document is the following. Here we have some terminology that we're using, right? The SDR, DDR, energy, stuff like that, right? And other things. I did talk to the die-to-die team, the bowl team that meets on Wednesdays, and one of the
I'm
important
sorry. Which team?
that's the bowl team.
The boat team. Got it.
Yeah. but
Yeah.
they're talking the die-to-die stuff, in general. The bow has expanded beyond its original die-to-die spec to be bow memory, bow flexi, bidirectional bow, things like that. So I'm gonna call it just the die-to-die interface team. So I did talk to them about what we are trying to do. One of the feedbacks I get is that our terminology is a little bit off from what they have in their in their white paper. And this is this white paper. This white paper talks about one thing it tries to do is standardize how are die-to-die interfaces, what standardize the data in terms of marketing data and some of the power data, how it should be measured. For example, when somebody says the power for my die-to-die is this much, it's not always clear what is included in that power, right? Where does the power measurement start and where does it end? Or where does when somebody talks about latency, same thing, right? When somebody says my latency is this much, what exactly do they measure? Do they measure just the IO to IO? Do they measure some of the circuitry before that? How much of that circuitry and so on? So this paper talks about the some of these parameters and so on, right? Area, what should be included in area, and things like that. So this is when somebody wants to market their die-to-die IP, they should take a look at this and how the number they represent, what's included in them and what's not. But the reason is some of the terminology, right? For example, we had just LDR and DDR and NRZ. They have slightly different terminology. We didn't have. I think I saw PAM3 in here, right? Once you start reading through a document, you're going to see PAM2, PAM3, and so on. So when we think about what and how to represent data, it would be good to follow this terminology so that we have a kind of we're not talking two different languages, right? It would be good if we call the same thing the same way, right? We don't call it something else when we mean the same thing.
I just opened that link. It doesn't look like the same document you're sharing.
So the link I sent should take you to this page, right?
No. Oh, there's a link inside of there. Okay, got it.
Yeah, you're right.
Now,
Yeah,
okay.
click on that. This also, you can see how kind of to use the search function of the contribution database, right? You search for white paper, you search for open chiplet economy, and then you say metrics, and it will pop up in there, right? It will give you this white paper. Okay. So let's see.
What page are you on?
This is, I switched again to the meeting minutes. Let me, because I needed to do another copy paste here, right? Okay, I need to do. All right, it wants to put numbers. That's fine. Let's take these things off. Okay, here we go. This a little bit better. So just do the copy paste of the meeting minutes in here, so we can use this document from here onwards. And maybe
so that's good.
This document, I'm just reading the executive summary. So this is trying to standardize on defining the characteristics, specifications of a PHY, correct?
Yes. Yes. Yes.
The focus is on standardizing the performance metrics of the physical layer,
Yes.
particularly the context of electrical interface layer IP. Okay. So essentially this this is a machine readable format to describe the electrical characteristics, with respect to SI and PI for the PHYs inside the chiplets, right?
They do not. So
Well, it's a
there's a couple of
PHY, right? A
yeah,
PHY is a piece of
right.
IP in the context of the CDX world. A PHY is not going to live standalone. It's a piece of IP that's going to go in a chiplet, right?
That's right.
Yeah.
So this white paper does not talk about machine
So
readable
Tony,
format.
we lost you, but is
What?
it on my end?
I
What?
heard Tony.
Sounds like you have a problem, Pratush.
Yeah.
Internal facing IO on the chiplet.
Say again?
So it is applicable to all the IOs on the chiplet. They could be die-to-die IOs. They could be die-to-package IOs to the PCB. They could be outward-facing IOs also. And yeah,
Well,
everything else
yeah.
is as you said.
All PHYs, right? Whether they're chip to chip or die to die, does it include just single-ended, differential IO buffers by regular IO, or is it strictly for PHYs?
It's all.
All. Okay. So
Yeah.
All right.
Yeah. So a couple
So
of
David, yeah. Sorry, go ahead with your thought first.
this work, what I'm sharing right now, is a little bit different from what we are trying to do.
Agreed.
In the way that the most important difference for me is actually there are two very important differences. Number one is this does not define any file format or anything like that, right? And they didn't mean to define that.
Mm-hmm.
What they meant to define is what metrics are there for a and I think the focus is on die-to-die interfaces, although I think they left it open for anything, right? Any for example, optical interfaces and things like that definitely would be covered by this. But what the idea is when one is the metric, right? That okay, right? If you have to provide power, for example, right? And you have to define what is the data rate and stuff like that. But then they take it to the next level and say, okay, when you say power for this IP is this much, this is exactly how you measure power, right? Or when you say the latency is this much, this is from which point to which point you measure latency, right? To avoid marketing gimmicks, right? I think all of us must have seen marketing people getting creative about how they define certain things, right? Then further on, they really do not dive into the particulars of electrical particulars of a given IP, which is what we would like to do, right? For example, nowhere here does it say about a clock mismatch, right?
So really, they're trying to standardize on the terminology of parameters used to specify and describe a PHY, a transceiver.
Yes.
Okay. So
that at least at the first glance, when you look at two IPs, you can make a choice of IP A versus IP B, either on its performance, or you can see whether both would be compatible. Right. Here it talks about single-ended, differential, and simultaneous bidirectional, right? Full duplex and half duplex, right?
Right.
Talks
Okay.
about what a period is. What it talks about when you say swing type, what are the possible choices, right? So that there's no misunderstanding.
Mhm.
What kind of clock it is, termination and stuff like that. I think there is a lot of stuff in here we can reuse
Yes. I
and
agree.
just
Yep.
right and populate the stuff that we really need to, the stuff that we want to add.
Okay. So this essentially would give us a specification to create a format to describe the electrical performance of transceivers.
In a machine readable format, right?
Right.
Yeah,
Right.
yeah.
Right.
Yeah.
Yeah. And again, that could be for a standalone PHY, but that could readily, in the packaging world be instantiated into a chiplet. So if we had a chiplet model, we could have an electrical description for those transceivers, internal or externals.
Correct. And really, the level we want to get to is the electrical description to be in a way that would allow at least some automation in terms of simulation setup and one, setting up the simulation, and two, checking the pass fail for the simulation.
Yeah, another use I could see in IP selection, right? If you're shopping around for a chiplet or even a PHY for that matter, you could, let's say you have one chiplet that has a PHY with a certain set of specifications and you're doing a custom chiplet, you want to find something that's compatible, right?
Correct.
Right.
Yes.
And the secondary use, so that would be more in the chiplet / IP selection, which is kind of in the scope of the part model, right? And then, for use in design flows, that could then essentially be used to define and specify the channel requirements, right? Because
Correct.
you need three things to define, the overall signal path, right? You need, to dumb it down, we need IBIS models for both sides of the channel, and then we need the channel specifications, right?
Yes.
Okay.
Yep. Exactly.
Okay.
So
Yeah. So this
we
is.
need to add one more thing.
I've been thinking about it, and so it sounds like that's what you're thinking about as well, David, right?
Yeah.
Okay. All right, I'm with you.
So Tony and
Yeah.
David, we need to add one more. We will also need to think about the.
Pratush, we could just about hear you.
I'm so sorry. Is it any better?
That's better. Yeah.
That's
Speak
better.
loudly. Yeah.
I'm much closer now. Okay, yeah. So the other thing I think we are missing in the scope of the document currently, David, is all the STA specific information that we need to put, because we'll be running chiplet to chiplet STA flows.
STA, well, that's a different discussion. When you're looking at timing interfaces, say within a chip or in chip to chip, you're either going to do a SPICE simulation using IBIS models or IBIS AMI, or you're going to be using STA. And STA is only applicable for low speed kind of single-ended signals. And that's a totally different specification, right? Because you need a .lib model for that type of analysis. Here you need an IBIS, which is essentially a lookup table SPICE model. So
Yes,
I think
Tony.
we need both, but this is assuming you're going to use signal integrity analysis for everything, which you can do. And in fact, That's what Micron does when they provide an IBIS model for their chiplet. It includes all the I/O, not just the high-speed I/Os. So that means if you
Actually,
do pin-to-pin type of analysis, you have to run SPICE.
But I'm
Tony,
also
actually,
thinking from Tony. I'm also thinking from a PNR flow perspective for the 1,000 chiplet package, right? This standard needs to address that level of scalability.
Yeah, but that would be for the non-high-speed PHYs, right? Because you cannot run STA at a gigahertz frequency. Problem with STA is it's based on a .lib, and the timing calculators, at least in modern, synopsis essentially, or cadence, it uses a simple RC delay model. And when you start getting into higher frequencies, that's not sufficient. You need an RLC model. So, we actually looked at this, and we ran STA on a long trace and an interposer, and we found significant delays between, a simple RC delay with, based on STA versus running SPICE.
yes.
So I think, you can use STA, but you have to bound where it's applicable, right? Once you get over a certain frequency,
Yeah.
and there's limitations to the Liberty model, right? I mean, it's basically a table lookup model, and it's just using simple RC parasitics for your load. So,
I agree with all that, Tony. I agree with all of that, but when we look at die-to-die interface, it's probably very short reach. It's less than a millimeter length. It's really comparable to on-die trace lengths, right?
It's a very high frequency produce, right? At those at 16
if you're
gigahertz.
going to very high gigahertz, but definitely if you're going beyond gigahertz,
right. So that might be useful information even to put in the chiplet, like, warning, do not, you cannot use a .lib on these IOs, right? I mean,
yeah,
you're not going to get a .lib model for a PHY.
Yeah, actually, Tony, I have a question. We say, or right, it was said that that there is STA done at the full package level, correct?
Well, yes, we said that. That's in our white paper. And you can do STA for low speed signals, internal and external die-to-die, right? Whether or not anyone is doing that in the industry, I don't know.
So Tony, the UCIe 3D spec PHY layer is STA based. It's really flop to flop delay modeling there at the 3D interface that UCIe.
Okay, but
because it's not really a PHY, it's IO buffers.
That's right.
Exactly.
It's 3D. It's 3D, and for 3D, RC still mostly works.
Yeah. So we have to keep that in the scope here, right?
Because the L is so short. So is there a PHY? I suppose there could be a PHY for 3D, but typically I think most what I've seen in the literature is you're just using special standard buffers, right? Because you can do logic.
So Tony, one anecdotal example we have from industry data now, I won't mention the name, but one of the 3D PHY companies is, you have to call it a PHY because they are adhering to the CDM 5 volt requirement, right? So they're
providing that as a piece of hard IP?
Yeah.
Okay.
It'll be coming from the foundry.
Okay.
Yeah. But produce apart from the PHY, right? Really, here we don't necessarily want to model the PHY. I mean, PHY is one aspect, but really what we're interested in is the PHY on a chiplet that's being sold in the marketplace, right? So now, right, the difference here for 3D is will there be a 3D chiplet that I can buy from somewhere and put on top of my chiplet?
Perhaps.
Likely impossible, but
I mean,
very low likelihood. Yeah.
Yeah, one example might be a sensor chip or something with a a memory, and you can build whatever logic. I think there's nothing out there today that I'm aware of. Although there may be sensor companies that are selling standard chiplets that can be used when you do a 3D stack.
okay.
So I think
Do we?
I don't think we should preclude the ability to do that. That may happen. To my knowledge, other than sensors, it's not happening today, but it could.
Yeah. No, I definitely don't want to preclude. What I'm getting to is that that workflow doesn't seem very well defined today, right?
Yeah.
If somebody is giving you a 3D chiplet, what is it that they have to give you that you want to do STA with both chiplets on top of each other? Right.
I wanna go back to this. Tony, I agree we could not preclude, but if you look at
You're
the
fading
enormous,
again, Pratyush. You're
I'm
fading.
sorry. I'm saying that the enormous challenge involved in doing 3D co-design, because you'll have to align every single 3D interconnect between the two designs, all the IOs. So it's an impossible thing for hybrid bond kind of technology because of the sheer number of IOs. You cannot
It's a place
standardize.
and route. Yeah, it's really a place. It's going to be done by place and route. You're not going to have a hybrid bonding chiplet that's going to be reusable. I would agree with that. But there may be a sensor that's top, and your top die would have a coarser, probably not a hybrid bonding, or
we could still attempt to standardize it in microbump space.
I think we're covering corner
come up with
cases.
very strict physical footprints patterns for the IOs there in the standards body.
I think we should focus right now on 2.5D. I mean, we should make note of that, because you bring up a good point.
Yeah. So
but again, for 2.5D, for high-speed interfaces, you're going to use SI analysis, spice level. You could use spice level analysis, SI, for low speed, or you could use STA.
So Pratyush,
do STA, you would need to provide a .lib for the chiplet.
Yeah.
Right. And essentially, the way I described it in the white paper that we did is you're really just focusing more on IO timing. So it's analogous to doing top level chip block to block timing, right? You're just looking at those interfaces. So you create kind of an ILM model for your blocks. You would create a ILM type model for your chiplets. Now you could do full STA on the whole chiplet, but then it's hard to do full STA on a chip. But if you have a system of multiple chips in there, the practicality of running STA for 1,000 chips is not going to happen ever, right? Or maybe 3 chips. So we did some simple things back at eSilicon. We were just looking at simple direct access, low speed signals between an HBM and the main die. It was just a single die. And we did find that there was some significant delays on those traces because they weren't really we didn't even write constraints. So those signals the specs are so loose on that you would have to try to make it not work, but it is possible. So that's why we do recommend that any path is timed, even if it's so so we just kind of looked at it and knew the specs were wide enough. We didn't actually run STA analysis, but as we started developing the flows, we did build an STA flow, and we did find that there was significant differences in those, even though those, well, it was significant, but you know, it was tens of picoseconds, but for like 100 megahertz, who cares? But if it was a very high speed, it would be a care. And at some point, you could break timing depending on the specifications of that path, that timing path.
Yeah, yeah. Pratyush, to your concern, whether we're including 3D, the way I'm thinking about it, I don't think we are recording it in any way. Right. I know that this paper talks about PHYs, but really what we want to take from this paper is the terminology and metrics to some extent, and then really apply that to the chiplet level. Right. Once we get to the chiplet level, there's really doesn't matter what the phi power is, right? Because the phi power is already part of the rest. But at the chiplet level, what we want to know is which are the pins, what kind of interface it is, and defining the interface is obviously open to future definitions, right? Anybody would be able to come in and say, hey, I have this new interface here. Here's the clocks. Here's the data. It's double data rate, blah blah, right? But really, we're thinking about the chiplet level. So if you think about a chiplet, whether it's 2D, 2.5, 3D, it's really about the same, right? We have pins and bumps. We assign them to an interface. We say this is what the interface is. And then we would go into the electrical specifics of each pin from that interface. Specifically for 3D, I think it's going to be a little bit simpler than 2.5D and 2D and so on, right? Because in 2D, 2.5D, you start talking about double data rate. You start talking about, you have the differential clocking, right? So you start talking about clock mismatch. You start talking about data to clock skew, right? Bit skew and so on. You start talking about voltage swings and weird stuff like that, that when you get to 3D, that really mostly doesn't apply anymore, right? Right. You won't have PAM4, for example, on a 3D chiplet, right? It just doesn't make sense to do it. It's not needed.
No, I
So,
agree with that.
right.
Yeah, I agree with that. But I'm just looking at a 3D design methodology for this 3D UCIe, very high density interconnect, right? So we'll have to have a support for chiplet integration there. And that'll be only in the packaging will they actually run full timing path across the two dies if they have that interface. It won't be run at the individual die level, right? So
it should be run not really at the packaging level, right? The way I'm thinking of packaging is once you have the copper pillars on the bottom or bumps or something like that, and you have some kind of interposer or substrate. Really, what you're talking about being able to run two chips together.
Yeah, it's going to be STA.
Right.
It's going to be an STA there. Yeah.
Yes. And then that problem is going to fall into the chip design flow.
That's 3D placement.
I see. So
yes, I agree.
So we don't need to add that .lib support in XML as such. Or I mean, it's already included in the CDX model.
I think shorter term, bigger fish to fry. The jury's about how that's going to be. Yeah.
So, I think what the answer to your question is yes, with slight qualification. So the CDK checklist that lists what models are necessary does list Liberty for STA.
Yep. Yep.
Okay.
So, David, you were talking about, and it's really at the package or system and package level, the way, and this is similar to what an interface-based design approach that, the idea was, we would instantiate a UCIe or a BOW or a HBM, right? And we do have the ability to define standard IO nomenclature to the pins, so we know it's a certain type of PHY, and we could actually put physical footprints for those PHY. And the idea, if you had that on each of your chiplets, you could just say connect this UCIe to this UCIe kind of through a script, or even interact, in a floor planning tool, and it would be smart enough to figure out all the signals that need to connect from PHY 1 to PHY 2. But if we extend that concept, in theory, we could, ascertain, the electrical characteristics of each of those PHY, and then derive the channel requirements, and then that becomes the spec for your signal integrity analysis.
Correct. Yes, but that's basically the idea. Extend the interface-based design to signal integrity in a way that basically, right, we capture the. Here's the one of the main problems is to set up and validate SI simulation. There is inordinate amount of time spent combing through standard specification and IP-specific data.
Exactly.
Right?
It's done manually by looking at data sheets. That's how it's done.
Yes. Yes.
Yeah.
Even if it's the dumbest tool that just sets up the main parameters and sets up the eye diagram check, that's a improvement over where we are today.
So let's pause for a second. We have two SI experts on the call. You guys think we're crazy, or you think this is a worthwhile thing to do? Talking to Mohammed and John.
Yeah.
It's
not us, obviously.
So Tony, I certainly don't think it's crazy. I think some of the implementation of some of the specs, right, that gets a little bit into how each of the EDA vendors wants to kind of run that validation.
Well, that's the point. We want to make this EDA neutral. So by coming up with the standard, we're going to try to get the EDA vendors to support this standard.
Yep.
So, yeah, I mean, today you're going to have to, but it's still, I mean, you need all this information even to set up your tools, and then manually, until you have it's supported by your tools, you're going to have to manually enter that information. But still, we're providing some automation to at least create those specs.
Get in those values. Yep. Yeah, it's obviously a big value add. So I think it's certainly worth pursuing.
Yeah. So Tony, one thing I was warned by the Bow group is that there's actually quite a customization and in terms of making SI simulation work and pass, right? That there's so many different cases and corner cases and specifics that probably we cannot cover the entire space. But
yeah.
I think it's worth the effort to get at least the minimum data in and see what happens from there.
The way I would view it, this allows us to do predictive analysis. You still need to do sign off, right? You still need to get the detailed models from the PHYs but you don't want to be having your high-powered PI guys doing this when you're just doing brainstorming with chiplets, with PHYs and stuff.
Yep.
And when you're doing your architectural planning analysis, trying to evaluate IP and stuff. So that's where I think this could be useful in the architectural planning and analysis phases. And as you're designing your chips, but at some point it's going to run out of gas. But the idea is this can get you pretty far along. I mean, really, from a package design, you're just trying to get those channel requirements, right, and then make sure those channel requirements are good. When you run the analysis, you're just going to plop in the IBIS models at either end, right?
Oh yeah. Yeah. Definitely. You're going to plop in
And
there these
then
models.
somebody's
Yeah.
going to have to review that spec that, came out of this first order analysis and say, yeah, that looks pretty good, but, X, Y, Z, we have to do this and that. So, eventually you're going to pull that expert in. But the idea is we want to be able to do as much as we can before having those, experts come in, very early in the design process.
That's right.
Yeah.
Yeah, because experts are usually very good at doing the detailed work and analysis. And for early analysis, that's gross overkill most of the time. So, yeah. No offense meant, John and Mohammed.
Can take it.
Okay, yeah. Okay, so maybe we should all take a look at this white paper.
Yeah.
See what's in it, what's missing. Maybe for the next time I can have a little table that kind of what's in this white paper and what I think we're missing. And John, if you can come up with a zero order list of parameters that we would need for that predictive analysis, that would be great.
Sure.
Yeah. And one thing
Yeah.
to think about is probably, so you see, for example, they have channel requirements for at different speeds. Bo does not. Bo just has a budget, right? And you just calculate what it needs to be. And if it's there, it's there. If it's not, not, right? Well, UCA puts explicit limit on the instruction loss and return loss on the channel, right? So, which is kind of cool, but yeah, probably we should think about how much of that is needed and how do we represent it. Yeah, so I can create a little table that kind of captures what's in here and how much of this stuff do we need and what is it that that's not captured in here. And then John, if you can, that zero order list would be good first step.
I'll have for next time.
Take a look at this list of things we talked about. Again, there was only when I was talking to JP, only one of us was the expert, and I was not it. So I may have captured something that's total nonsense. Feel free to whack it and rework it and delete or add whatever you think if something's missing. Okay, I need to drop off a little bit early today, and I need to get to my next meeting. Do you guys want to continue, or should we? Any other thoughts from anybody? What do you guys think? Did we beat this topic enough for today?
Yeah, no, it was good discussion.
Okay. Any other thoughts from the other folks? Boone, with you,
Nope.
Michael, Vikas.
No. Sorry, David. No, nothing from my side there.
All right. All right, very good. So I'll talk to you guys in 2 weeks about SAPI. Next week, we're talking about test. All right, have a good Thursday.
Righty. You too, Dave. Thanks.
Yeah, bye.
Bye.
Are you on the phone? Tony?